Good morning, class. Myself, Mrs. Monica Pare. Welcome to Science class, Standard 7. Chapter number 3 is going on, Properties of Natural Resources. Yesterday we have covered what are the natural resources, which are the natural resources. From that we have seen that air, water and soil we are going to study. With that we have started the air properties. From that we have explained or we have seen these two experiments, and we have come to the point that air has a mass and weight. Even yesterday we have seen the definition of atmospheric pressure. The molecule of gas in the air are in constant motions. When these molecules strike a body, they create a pressure on that body. This is the pressure of air that we called as atmospheric pressure. Again, by this injection pistons, we have seen the property of air that we can infer that atmospheric pressure is same in all the direction. Today we will summarize these points and we will move forward. Properties of air. Air is mixture of gases. Which mixtures are there that we have seen already? Air has no shape. Air does not have any shape. Air has mass and weight. In a case of balloon experiment, we have seen that air exert and pressure is called as atmospheric pressure, and it is same in all the direction. Air is affected by the temperature. Air takes up space. Air pressure can be compressed. Air regulates the temperature of Earth's surface. Air is useful as a medium for transmission of sound. Few above points we have discussed with the help of experiment. Below few points we will discuss now. Now, before we start with that, we have one question under the find out. Is there any atmospheric pressure on the moon? As we know, there is a vacuum on the moon's surface. So, as there is no medium, there will not be air. So, as if air is not present, there will not be atmospheric pressure. So, answer for this is there is no atmospheric pressure on the moon as it contains the vacuum. Next we have the information. In this we will see what's the pressure above the sea level. Under an ordinary condition, atmospheric pressure at sea level is about 1,01,400 Newton per square meter. Newton per square meter is the unit of it. It can be measured with the help of barometer. As we go higher above the sea level, atmospheric pressure goes on decreases. Means at the level of sea it will be higher, and as we goes upside it will be rarefied. That is nothing but it will goes on decreasing. Little fun. I'll just read out this slide and you will going to experience this experiment with the help of videos. Place a piece of cardboard on the mouth of glass filled completely with the water. Holding the cardboard firmly in the place with one hand, invert the glass quickly. Take your hand away from the cardboard. What do you see? This experiment you have to try in home. It's the harmless, and every year we are performing this experiment in the class. As it's because of lockdown it's not possible, you can try it in home. When the school will start, again we will take it in classroom. But make sure that glass is completely filled with the water, and whichever card sheet or cardboard you are taking, it's having some glossy cover so that it will be stick properly. We'll take this point also, so togetherly these all points you will see in the video. Great scientists. In 1726, Swedish scientist Daniel Bernoulli put forth the important principle that the pressure of air decreases when its velocity increases, while the pressure of air is increases when its velocity goes on decreases. If a body is moving through air, the air pressure decreases perpendicularly to the directions of a motion, and then the air is in its surrounding flows rapidly from the higher pressure to the lower pressure. From this you just understand that when the pressure of air will decrease, the velocity of it will goes on increase, and if the pressure of it will increase, the velocity will goes on decrease, and vice versa. Means they are inversely proportional. What's mean by the inversely proportional? When the one thing is goes on increasing, another thing goes on decreasing. As much as first thing will increase, that much portions of the another thing will goes on decrease in this manner. So just remember, they are inversely proportional to each other. As the pressure decrease, velocity will goes on increase, and if the pressure will increase, the velocity will goes on decrease. Now here in your textbook they kept it blank so that you can download the photograph and paste it here. But rather than pasting in a textbook, just mention the scientist name, and under the chapter heading of third, properties of natural resources, paste this photo in your notebook by writing the scientist name. And one more thing to remember from this, as much when the air will start flowing rapidly, it will always flow from the higher pressure to the lower pressure, and about that decrease perpendicular to the direction, this we will see with the help of one experiment. So this, as much as the higher velocity, the lower pressure will be there, and it's the net force on a paper upwards. It's the paper, by using the paper they have shown this one. Now if the velocity will lower, the pressure is goes on increases. It's the picture of the scientist Daniel Bernoulli.
Good morning, children. Today we'll talk about one necessary element of life. So, what all things are necessary for life? Can we live without sunlight, water, soil, and air? No. They are some of the important elements of life. Without them, we cannot live. So today we will talk about air. Why is air important to us? We humans and animals need air for breathing. Plants need air for making food. Where all is air? Air is all around us. Although we can't see it, but we can feel it. Do you know what is air made up of? Air is a mixture of different types of gases. So, what all gases are present in the air? Mainly, there are three types of gases: nitrogen, oxygen, and carbon dioxide. Of these gases, nitrogen is the largest amount, that is 78%. Next is oxygen, which is 21%. The carbon dioxide is even less than 1%. Although the percent of carbon dioxide is very less, but it is important for the living world as plants use it for making food. In addition to these gases, there are many other gases present in small amount. Additionally, there are also small particles floating in the atmosphere such as dust, water vapor, pollen grains, etc. Air is so important to us. So, to know more about our airman, let us do a small experiment. Take a stick, two inflated balloons, and a thread to balance the balloons. Now tie the inflated balloons at each end of the stick. Tie the thread to the middle of the stick to hold it up. What do you observe? You will observe that both the balloons are balanced on the stick. Now prick one of the balloons, say the pink one, with a pin. The stick end with the inflated balloon goes down. Why is it so? Let us understand this. Look, who is there in the inflated balloon? It is our airman. When we prick the pink colored balloon, airman just rushes out of it. And so, with the airman still inside the blue balloon, it is heavy. This proves that the airman inside the balloon makes it heavier, and this means air has weight. Now, something interesting about our airman. Take an empty glass and a bowl of water. Fill the bowl with water. Hold the glass upside down above the water and push it slowly into the water. It is difficult to push it, isn't it? Push it more. Still, water hasn't been able to get into the glass. Tilt the glass a little. You can see some bubbles coming out of the water. What do you understand from this? From far, it seems that the glass is empty. See closer. Who is inside? It is our airman. He is trapped inside and cannot come out. But when we tilt the glass, the airman rushes out of the glass. With the airman gone, it is now possible to fill the glass with water. Interesting, isn't it? So we see, even airman can be trapped. More about the airman. Till now, you know that we need oxygen for breathing. What else it is needed for? Let us find out. Take two candles and a glass jar. Light the two candles and cover one of the candles with the glass jar. After some time, we see the flame in the covered candle is put off. Why? Here we see the airman keeps encircling the candles and they continue to burn. When one of the candle is covered, the airman cannot reach the candle. When the limited oxygen in the jar is used up, the flame is put off. And the other candle, which airman keeps encircling, gets its oxygen supply from the airman. And it continues to burn. So we see oxygen is necessary for burning and airman provides the oxygen. So, not just for breathing, oxygen is also necessary for burning. What else can our airman do? For this, take water, a glass and a piece of stiff card paper. Fill the glass with water till the brim. Cover the glass with the card and hold the card firmly. Turn the glass upside down. Slowly take the hand away from the card. Oh, what is this? The card does not fall. It holds the water in the container. Is it a magic trick? No. Let us find out what actually is happening. Look, the airman below the card is pushing against the card. It is hard enough to keep the card in place. So we conclude the airman pushes in all the directions, even upwards. That is all for today. Bye bye, kids.